Hello, Integrated Math 1. Welcome to Module 2, Topic 2, Lesson 4. We're doing Part A, actually. We're doing Day 1 of this lovely lesson. We broke it up a bit, just to kind of help it get things going. So we've been playing around with inequalities a little bit. We kind of played with them in our opening activities there, but we're not going to push it a little further into something that we call compound inequalities. We're going to start off just by focusing on writing those. So we're on activity 4.1 on page M2-137. And here's the deal. GoodSportsBuy.com is an online store that offers discounts on sports equipment to high school athletes. Very nice of them. When customers buy items from the site, they must pay the cost of the items as well as a shipping fee, right? You have to pay to get it to where it's going, right? FedEx is not free, UPS is not free. Even if you have Amazon Prime, they say shipping is free, but you pay for it with your Prime membership. So they must pay the cost of the items as well as the shipping fee. So at GoodSportsBuy.com, a shipping fee is added to each order based on the total cost of the items purchased. So how much you buy will determine how big your shipping fee is. If you buy more, it's going to be more stuff to ship, so it's a larger shipping fee. So I have this lovely table, and you have it too there on page 137. This lovely table provides the shipping fee categories for GoodSportsBuy.com, and I have that right here. So the total cost of the items, if it's from 1 cent up to and including $20, it's $6.50. If it's more than $20 up to and including $50, it's $9 shipping fee. If your cost of your items is between $50 and $75, they're going to charge you an $11 shipping fee. If the cost of your items is from $75 up to, but not including $100, your shipping fee is $12.25. And if you bought $100 or more worth of stuff, then you are going to pay a shipping fee of $13.10. Now, this looks kind of confusing, right? And a bit much. So here's the deal. We can use inequalities to represent the various shipping fee categories at GoodSportsBuy.com. So we can actually write inequalities to help us out with that. So if you let X represent the total cost of items purchased, you can write an inequality to represent each shipping fee category. So what you're going to do here on question number 1 for parts A, B, C, D, and E, there's 5 of them because we have 5 rows here. You're going to write inequalities for each of these, which means they've set it up for you, but you need to read through the table carefully and decide if X is less than, greater than, less than or equal to, greater than or equal to, and that's what you're going to put in those blanks. So read carefully your lovely little table and go ahead and fill in the blanks on question number 1, part A, B, C, D, and E. Go ahead and hit pause to work that out and then hit play when you're ready to check your work. So $6.50 shipping fee, here it is. If my total cost of items 0.01, that's cents, right? 1 cent. So if I pay 1 cent and up, so it includes the 1 cent, then that's going to be in there. So that means X can be greater than or equal to 1 cent. And of course, it says up to and including $20. So it does include the $20. So I want to squash the equal sign underneath that. But it's between 0 and 1. So this means that, between 1 cent and $20. So that means it's the stuff less than $20. So less than or equal to. For part B, more than $20. Oh, so X should be greater than 20. That one was easy, right? More than $20 is greater than 20. And so more than 20, but still less than 50. Ooh, and including 50. So that means less than or equal to 50. Great. For our $11 shipping fee, let's see, it says between 50 and 75. So if it's between 50 and 75, that means it's greater than $50 and less than $75. Notice it wasn't including on that one. Yeah. So X is greater than 50 and X is less than 75. That's good. For part D, it says from $75 up to, but not including $100. All right. We got to think about this. So 75 to 100. Well, that means it's more than 75 It does include the 75, so I'll say greater than or equal to 75. And not, it says up to, but not including 100. So it's up to 100, so less than 100, but it doesn't include it. No squashed equal sign. So I'm going to say less than $100. So X is greater for my $12.25 shipping fee. X is greater than or equal to $75, and X is less than $100. Good to notice. And last but not least, that $13.10 shipping fee, dude, if it's just more than $100, right? $100 or more. So that sounds to me like it includes $100. And of course, if it's more than $100, that's greater than. So we'll say that X has to be greater than or equal to $100. Yay. So now we've written these inequalities for parts A, B, C, and D. And I want you to kind of compare them for just a moment because this brings us to something called compound inequalities. So a compound inequality is an inequality that is formed by either the union or the intersection and of two simple inequalities. So if you have two inequalities, and in between them, you see the word or you see the word and. That means it's a compound inequality. So anytime you have two inequalities and you see an and in the middle or you see an or in the middle, you're dealing with a compound inequality. We refer to the or as a union and we refer to the and as an intersection. We'll talk more about why we say that in just a little bit. But what I'd like you to do right now is go back to question number 1, parts A, B, C, D, and E that we just did. And I want you to tell me if any of those are compound inequalities. Do they have two inequalities with the word and, two inequalities with the word or? Go ahead, pause, write down which ones are compound inequalities, and then hit play when you're ready to check. So I'm going to scroll back a little bit so I can see them. I'm going to come back here. So here we have A, and I have two inequalities with an and in the middle. That's a compound inequality. For part B, I again have two inequalities with an and in the middle. Also a compound inequality. For C, I have two inequalities with an and in the middle. It's a compound inequality. D, also two inequalities with the word and in the middle. Also a compound inequality. Oh, but not E. E is just one inequality. In order to be a compound inequality, we have to have two with either and or in the middle, and E doesn't do that. So it looks like parts A, B, C, and D are all compound inequalities because they all had two inequalities and they had that word and in the middle of them. So we're going to play a lot more with compound inequalities. Let's look at two examples of compound inequalities. So here I have X is greater than 2 and X is less than or equal to 7. So this is a compound inequality. It has the word and in the middle of it. That's our giveaway here. So this inequality reads as all numbers greater than 2 and less than or equal to 7. Yay. What's nice about these little and inequalities is these and compound inequalities is you can actually write them in compact form. All right, because we're saying X has to be bigger than 2, but it also has to be less than or equal to 7. So we can squish it down into one, least to greatest. So from 2 to 7. It's everything in between those, right? So the way we write that is we say that 2 is less than X is less than or equal to and less than or equal to 7. So notice how the X is in the middle because that indicates that X is everything in between that 2 and 7. Oh, and also including the 7. So X is still bigger than 2 because alligator eats the bigger one, just like we had here. And X is still less than or equal to 7, just like we had here. It's just nice that we can compact it down. So whenever you see these compound inequalities that use the word and, you can write it in compact form. It just always make sure you go least to greatest so that your inequalities are always facing the same way. It works better that way. Here's an or one. We haven't seen these yet, right? We've only been dealing with the ands, but we do also have ors. Those are happening as well. So this inequality reads as all real numbers less than or equal to -4 or greater than 2. Yeah. Now, I'm going to point something out here. Because this is an or, it's a union, it's not an intersection. Notice it's not the stuff in between anymore, right? This is stuff less than or equal to -4, and it's also stuff greater than 2. It's not the stuff in between. So this means that we cannot write ors in compact form. Only compound inequalities containing the word and can be written in compact form. The or guys, you just have to leave them like that. You can't compact down your ors because it's not the stuff in between, it's the stuff outside. It doesn't work as well. So here's what I would like you to do. You noticed on that last question, on question number 1 on parts A, B, C, and D, we said they were all compound inequalities, but did you notice they all used the word and? Which means you can write all of them in compact form. So I'm going to go ahead, take you to number 3. So go back to question 1. Go back to the inequalities you wrote for question 1. And I would like you, for A, B, C, and D, I would like you to write all of them in compact form. You can look at the example on the earlier, further up the page, that's fine. Flip back over to number 1, A, B, C, and D. Look at those inequalities and write them in compact form. So go ahead and hit pause to write these down, and then hit play when you're ready to check your work. All right, I'm gonna do some work off to the side over here. So on part A, we wrote that X was greater than or equal to 1 cent, right? 0.01. Oh my gosh, I can't even write it. And we said that X was less than or equal to 20. So that means X is everything between 1 cent and $20. So that means I'm going to put my X in the middle. I'm going to put my 0.01 over here. I'm going to put my $20 over here. And we know that X is less than or equal to $20, but we know that X is greater than or equal to 1 cent. Oh, look, now it's in compact form. Yay. How'd you do with the others? Hang on, I'm gonna erase this so we can write it the pretty version. I'm gonna put the pretty version up. That's so pretty. I love it. What about the next one? So for our next level of shipping fees on part D, for that $9 shipping fee, we said you have to pay a $9 shipping fee if the cost was greater than $20 and less than or equal to $50. Okay, so that means we're going to go 20 to 50. And we know that X is less than or equal to $50, but notice X is the bigger one when it comes to 20, so X is going to be greater than 20, so we'll write it like that. Again, I'm going to erase this so you have the pretty version up. That's much prettier. All right, next up for our $11, when you looked back at that one, it said that X was greater than $50. So I'm going to write that down. And can't do a compact unless it's an and. And we said that X was less than $75. No squashed equal signs here. So fine, we're going to go from 50 to 75. We're going to put our X in the middle. X is less than 50, but it's bigger than, X is bigger than 50, but it's less than 75. Oh, I forgot my dollar signs. Shall we put them there to make them pretty? That's not very pretty, right? I'll give you the pretty version. Boom, there it is. Last but not least, our $12.25 shipping fee. There were bigger shipping fees, but this was the last of our compound inequalities with an and on it. So for this last one, we said if our total cost was greater than or equal to $75 and our cost was less than $100, that's when we paid the $12.25 shipping fee. So I got to go from $75 to $100. I'm going to put my X in the middle. We know that X is bigger than or equal to 75, and we know that X is less than 100. I'll give you the pretty version. This isn't very pretty. There, that's the pretty version. It's all typed and pretty, so nice. So yeah, compound inequalities are when you have two inequalities that have an and in the middle or they have an or in the middle. And of course, if they have an and in the middle, we can write them in compact form. So nice. I like compact form. It takes up a little less space, right? A little less space. It's not a bad thing. So let's play with these a little bit more. Here's the deal. We got a few more examples where we're just going to really play with these compound inequalities, but we're also going to start playing with them on number lines. That's what we're really going to start looking at. So we're on activity 4.2 on page M2-139. We're going to look at problems with more than one solution because that's life sometimes. Sometimes there's more than one solution. So water typically is a liquid. However, water becomes non-liquid when it is 32 degrees Fahrenheit or below, or when it is at least 212 degrees Fahrenheit. So to start, can you represent that on a number line? You're going to need to put some numbers on your number line, but can you represent for me on a number line where water becomes non-liquid? And we wrote it up and down so it looks more like a thermometer to make it easier. Go ahead and hit pause, fill in your number line, and then hit play when you're ready to check your work. All right, let's start with this. I'm going to number my number line. It makes it easier. So I'm going to count by 25. So 0, 25, 50, 75, 100, 125, 150, 175, 200, 225, and 250. I didn't have a lot of space, so I only wrote down like every 50. Made it a little easier. So let's start with this guy, 32 degrees below. Well, if that's 25 and that's 50, 32 is going to be somewhere in the middle there. And it is closed. It does include 32 degrees, so I'm going to put a little closed circle there. And it says or below, so I'm going to draw an arrow going below. So any temperature 32 degrees or below, we are no longer liquid. That's a true story. Of course, that's also true if you hit 212 degrees Fahrenheit or above, right? Because it says at least 212. So I'm going to put a closed circle at 212. If this is 200 and 225, then 212 is going to be right in the middle there. And of course, it's at least 212. So that means more than that would also be non-liquid, right? So fine. I'm going to draw my wrong way. I'm going to draw my arrow going up. So if I hit 212 degrees, my water is no longer liquid. And if I go higher than 212 degrees, my water is no longer liquid. That's not a thing, right? Don't drink that. Don't. So here's our lovely number line, and it is a lovely number line. Now here's what I would like you to do. Can you write a compound inequality to represent this information, this whole non-liquid when it's 32 or below, non-liquid when it's at least 212. And you can use that little number line that you just made to help you out. Go ahead and write a compound inequality to represent this information. Hit pause to write it down. You may want to define your variable. Hit pause to write it down. Hit play when you're ready to check your work. So you may have just used an X for your variable, but I was like, it's water, so I'm going to use a W. So I'm just saying, let W represent the water in a non-liquid state. If you use an X, that's fine. I'm just going to use a W for, water in a non-liquid state. So we said 32 degrees and below. So that would be less than, wouldn't it? And then we said at least 212 degrees would be 212 and above. So I wrote W less than or equal to 32 or greater than or equal to 212. And notice how it's an or this time. We said the and was generally the stuff in between, but or is not. Or is the stuff outside. It's not in between. It can be one or the other. It can't be both. So we used an or for this one. This was an or problem. Yeah. So let's give this some thought. Is that always true, sometimes true, or never true? Well, my conclusion here, it's always true. Because the truth is, if it's 32 degrees or below, my water is solid. It's ice, right? I mean, you can try to drink it, but it's not very drinkable at that point. You just have to kind of suck on it, crunch on it. I guess it depends on what kind of ice you have. Do you have one of those fancy crushed ice makers? Those are nice. I don't have one. Of course, if it's 212 degrees or above, it's boiling. Your water turns to gas and it's a steam. So this is always true. If it's below 32 degrees or above, and notice they even gave us the word or. Did you like how they even gave us the word or? Or, there it is, or. Make sure I've got the right or. It's right here. When it's below 32 or below, or when it's at least 212, it is not liquid. It's not liquid. At least water's not. Different elements have different boiling points and different solid points, but melting points, but not water. Yeah, don't drink it if it's boiling. That's bad. It'll hurt you. It's very bad. Let's go to another problem. Luke and Logan play for the same baseball team. They practice at the Lions Park baseball field. Luke lives 3 miles from the field and Logan lives 2 miles from the field. But we're not told direction here, are we? So let's give this some thought. What is the shortest distance, and we'll use a D, what's the shortest distance that could separate their homes? And what's the longest distance that could separate their homes? Go ahead and give this some thought. Hit pause, give it some thought, jot down your thoughts there on A, and then hit play when you're ready to check your work. Well, let's give this some thought. So if they live the same direction away from the park and Luke is 3 miles away and Logan's only 2 miles away, well, then that difference is only 1 mile. Difference between 3 and 2 is 1. So the shortest possible distance that could separate their homes is 1 mile if they're both the same direction from the park. But what if they're not? What if Luke has to go one way and Logan has to go the other way? So Luke goes 3 miles this way and Logan goes 2 miles this way. Well, suddenly that's not a difference anymore. That's a sum, isn't it? So the sum of 3 and 2 is 5. That means the longest possible distance that could separate their homes is 5 miles. Yeah. This one's a little sneakier, but we can do it. Write a compound inequality to represent all the possible distances that could separate their homes. Hit pause to see if you can write a compound inequality, and then hit play when you're ready to check your work. So we said that the closest they could live would be 1 mile. And we said the furthest apart they could live would be 5 miles. But it could be some combination in between, right? The directions are a little different, that sort of a thing. So it could be that distance could be between, could be greater than 1, could definitely be greater than or equal to 1, but that distance could also be less than or equal to 5. It could be anything in between, right? It could be as little as 1, it could be as much as 5. So D's got to be somewhere in between, and look what we just wrote. We just wrote the compound inequality that represents it. This is definitely a compact inequality, which means it must have used the word and in it. We didn't see the word and, but it was there. So let's go to part C. Let's represent this solution on a number line. Let's represent this on a number line. This is trickier, so I'll give you some time to kind of muse on it, have some thoughts on it, and then hit play when you're ready to see what I've come up with. So first of all, I need to number my number line. So that was the first thing I did. I numbered my number line -4, -2, 0, 2, 4, 6. And we said that it could be as little as 1. So here's my 1. So it could be as little as 1, but we did say it could be more than 1. Actually, I should make it go further. So we said more than one was cool. We said that a maximum, though, that the furthest they could live apart would be 5 miles. So that's over here. And that is closed in because it was equal to. And it could be less than 5 miles, but we said that was the most it could be, was 5 miles. Check it out. There's an overlap here, isn't there? And we did say that the distance had to be between 1 and 5. So here's what we're going to put on our number line. We're going to put a closed circle on 1. We're going to put a closed circle on 5. And then we'll color in everything in between. Because we said that distance could be between 1 and 5, greater than 1 and less than 5. So that means we get to color in between. So this is what we refer to as an intersection. This is why it's called an intersection, because if you look, this is where those two inequalities overlapped. It's where the intersection is. Aha. So one last thing then, just a little bit of food for thought. There's a lot of right answers here, but there is one way to write it that would be easier. So Luke bikes to Logan's house, right? They play on the same team. They're friends. He has already been biking for half a mile, 0.5 miles. What is the greatest number of miles that he may have left to bike to reach Logan's house? Go ahead, hit pause, write down your thoughts, and then hit play. Check your work. So he may, because we said that the distance might be only 1 mile, or it could be as much as 5. So he may only have to bike another half a mile, which is pretty close. It's not very far at all. But the question says, what is the greatest number of miles he may have left to bike to reach Logan's house? Well, the greatest possible distance is 5 miles. He's already done a half a mile, so he may have as much as 4.5 miles left to bike to Logan's house. It's possible, very possible. Let's do another one. Jody bought a new car. Ooh, Jody, look at her go. Jody bought a new car with a 14-gallon gas tank. Now, around town, she is able to drive 336 miles on 1 tank of gas. But on her first trip traveling on the highway, and if you guys don't know, your highway mileage is usually higher than your around town mileage. So on her first trip traveling on highways, she drives 448 miles on 1 tank of gas. So here's what we're gonna do. We're gonna start off with part A. We're gonna write a compound inequality in compact form, right? Because we know she could go as little as 336 miles, or she could go as much as 448 miles on that 1 tank of gas. So we're gonna write a compound inequality in compact form that represents how many miles Jody can drive on a tank of gas. We're going to let M represent the number of miles per gallon, because you already see a problem here, right? Because we can see miles, but her tank is in gallons. So see if you can get a little creative and write an inequality that's going to work for that. Notice they said that M is miles per gallon. We might have to use some of these things in conjunction a little bit. So go ahead and hit pause. See if you can write down a compact inequality for this, and then hit play when you're ready to check your work. So the first thing I noticed again was those units, right? I have 14 gallons, but I need it to be miles. So I realized if I did gallons times miles per gallon, that would actually solve my problem, wouldn't it? So because a tank can hold 14 gallons and M is our miles per gallon, that's our rate, isn't it? So I'm going to do 14 times M for the middle of my compact inequality. And again, we know that the least she would be able to get on that tank of gas is 336 miles. We know the most she'd be able to get on that tank of gas is 448 miles. So that's not bad. That's not bad. We have a lovely inequality here. Now it is a compact inequality. So here's what I would like you to do. Can you rewrite that compound inequality? And I'm gonna rewrite it up here, right? We just wrote it. 336 is less than or equal. Oh, my pen. Oh, my pen. You have it on your paper, but I want it on my screen so I can see it better. 336 is less than or equal to 14M is less than or equal to 448. Can you rewrite this instead of a compact one, can you pull it apart and rewrite the compound inequality as two simple inequalities separated by either and or? So separate it out and make sure you put and or in the middle of it. If you need to, you might want to go back and look at some of our earlier work to help you know what word goes in the middle and how to set it up. So hit pause, rewrite it as two inequalities with and or in the middle, and then hit play when you're ready to check your work. So first of all, the fact that it's compound, I know the word and has to be in there, right? The very fact that it's a compact inequality tells me it's the word and, because we said only ands will do the compact inequality. So I know there's an and in the middle. And this part of it is easy. So I'm going to split it up into this half and this half. So this half is easy, right? It's just 14m is less than or equal to, ooh, that's an m, sorry, less than or equal to 448. But for this side, I'm going to flip it around to make it a little easier to work with. So for this side, I've got 14m, and you can see alligator eats the bigger one, so greater than or equal to 336. With my word and in the middle. It has to be and. If it's a compact inequality, and is the only thing that can go in the middle, because only ands do the compact thing. So kind of nice. We were able to we know that compact means there's an and in the middle, and it's kind of cool the way we could be like, all right, there's one, there's the other. It's like they overlap, right? It's a cool trick. So what I would like you to do now is I would like you to solve each of these simple inequalities. So these two inequalities that you just wrote on part B, can you solve each one of those? And then once you've solved it, take that solution and put it back into compact form. Go ahead and hit pause to work these out. I know you've got this one. Hit pause to work these out, and then hit play when you're ready to check your work. All right, let's start with the first one, shall we? 14m is greater than or equal to 336. Fine, I'm just going to divide both sides by 14. Hey, we'll divide both sides by 14. Those cancel out, and this is why I need a calculator, because I don't have that memorized. And we'll do 336 divided by 14. Ooh, and I get 24. Hey, except for my pen, which is being a jerk. Don't be a jerk pen, be a nice pen. There we go. Our other inequality. What was our other inequality? 14m is less than or equal to 448. So again, divide both sides by 14. And because it's positive, I don't have to worry about flipping inequalities or anything weird like that. So that's nice. So I get m is less than or equal to, calculator time, 448 divided by 14 gives me 32. Beautiful. All right, last but not least, let's put it into compact form. So my m is going to go in the middle. I'm going to flip this around to do this guy. Because 24 is less than m, we can see that, so I wrote that. And of course, m is less than or equal to 32. Dun, 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 dun. Look at us. We solved it and we put it into compact form. We're amazing and magical. I know. Well done. Not bad. Sorry, it gets messy. So let's talk about what we just found. What is it that you just found? That's a great question. What is it that you just found? Go ahead and hit pause. Remember, you may need to go back, flip back over, and remember what M stood for. And then what is it that you found? Hit pause to write it down, and then hit play when you're ready to check your work. So, if you recall, remember that M was miles per gallon. Do you remember that's what M stood for? Miles per gallon? It was a rate. So what you actually found here, wrong button, is that Jody is getting somewhere between 24 and 32 miles per gallon of gas in her brand new car. Wow, 24 miles per gallon. She needs a better car. What is she buying? Do you think she bought like some big old, like, she must have bought something like a truck or a Jeep. Oh, Jeeps. They're fun. Jeeps are fun, but they get terrible gas mileage. Oh my goodness. My little car is small and compact. We get great gas mileage. It's usually closer to 40. I have an awesome car. His name is Pepe. One last thing I want us to do. Can you take those inequalities that you just got on C? Can you take that inequality that you just got on C, that you just wrote down for C? Can you please put it on a number line? Put it on a number line. Don't forget to shade and all that good stuff. Hit pause or put it on your number line and then hit play when you're ready to check your work. All right, so first of all, I'm putting numbers on my number line. I'm probably not going to get negative miles per gallon, so I've got 0 to 50 here, just lining it up. We had 24, right, which was, we said she could get as little as 24, so a good solid closed circle. We said she could get as much as 32, so I'll put a closed circle around 32, a little bit more than 30. And of course, she could get anything in between, depending on what she's driving and what she's doing. So I shaded in the region in between. Oh, yeah. All right, guys, how'd you do? I'm not sure, because if you start talking to the YouTube video and the YouTube video starts talking back, you might have some concerns. Anyway, I hope you found this helpful, and I hope you found this useful. If you have questions or concerns, please talk to me. Let me know. I'll help you out. And of course, feel free to come see me during office hours. I'll see you later. Bye.